this lesson is all about adding unlike fractions. First thing you need to know is that an unlike fractions are fractions with different denominators. So if you're trying to add two fractions and they have different denominators, then these are unlike fractions. We have to remember though that when we add fractions, the denominators need to be the same. You can't add sixths plus halves without changing to get a common denominator. That denominator must be the same. When you add fractions with unlike denominators, if you have an equation where you're adding 1/2 plus 1/6, first thing you need to do is to find equivalent fractions for both of those numbers, for both of those fractions, but they have to have like denominators. When you add fractions with unlike denominators, you need to find equivalent fractions with like denominators. So here's one way to add unlike fractions. One way is to use your fraction bars, and you should have these at home with you. And the example that we're going to work with is 1/2 plus 1/4. So there's three easy steps to adding fractions with unlike denominators when we use the fraction bars. Step 1, you're going to model with your fraction bars. You're going to place one 1/2 bar and one 1/4 bar together under the 1. And the 1 just helps you to keep everything in line and kind of see where your fraction's headed. So I put my 1 down, put a 1/4 and a 1/2 underneath side by side. So from this 1/2 plus 1/4, I can immediately see that the sum of these two numbers is going to be less than 1 because it doesn't go all the way to the end of the red bar. Step 2, find the fraction bars that together are equivalent to 1/2 plus 1/4 in length. So this means I'm going to look around in my bag, my fraction bag, and I'm going to try to find pieces that will fit underneath 1/2 and 1/4 that are all of the same denominator. So I might pull out a 6. Well, my 6 fit in here inside this box where my sum is going to be, because I'm adding 1/2 plus 1/4. So this longest box, this is my sum. So if I look in my box, I can find that the 1/4, I can put one there. Could do another 1/4, and I can do another 1/4, and I see that those fourths fit underneath my 1/2 and my 1/4 bar. So since 1/2 is 2/4, you can see here there's 1/4, there's 1/4, and they both fit under the 1/2, then I can see that 3 1/4 fraction bars are equal in length to 1/2 plus 1/4. So my 3/4, there's 1, 2, 3, fit on my 1/2 plus 1/4. So I can say 1/2 plus 1/4, my original equation, is equal to 1, 2, 3/4. So I just had to go through my bag until I could find pieces that would fit in that space. And it so happened that it was the fourths, and 3 of them fit in this space of 1/2 plus 1/4. Alright, here's another example using your fraction bars. This time I'm going to add 2/3 plus 1/2. Again, I'll notice that my denominators are not the same, so I have to find that common denominator so that I can add these two fractions. Well, I'm going to get out my 1 bar, and I'm going to place 2 of the 1/3, because I'm looking for 2/3. There's 2/3. I'm going to place those 2 bars under the bar for 1, so I've put those there. Then I'm going to place 1 1/2 bar beside the 2 1/3. So 2/3 is here plus the 1/2. Well, I can look at this equation, and I've lined it up underneath my 1, and I immediately know that the sum of 2/3 plus 1/2 is going to be more than 1 because it goes out past the bar here, and I can see that this is going to be greater than 1. So I have to find the fraction bars that are equivalent to 2/3 and 1/2. To look at my bag and find the pieces that are going to fit inside. Okay? So if I found that my 6 are going to fit, and I've got 1, 2, 3, 4, 5, 6, 7. Now in your bag at home, you're only going to have 6. So you may have to draw a box for 1 and scoot 1 over, or draw the box for the 1 at the end, because you're only going to have 6. Well, here I can see that 1/3 is equivalent to 2/6. Here's another third is equivalent to 2/6. And here I have 1/2 that's equivalent to 3/6. So my 6 pieces fit in there. They're the same length as my 2/3 and my 1/2. And so I can now add the fractions, and you have to remember to reduce. So I have 1, 2, 3, 4, 5, 6, 7 6. And I can look at that and tell that it's an improper fraction, and I have to remember to reduce. So I know that 7 6 is 1 and 1/6. And I can also see that up here with my fraction bars. I can see that the 1 is here, these 6 6, and I have 1/1/6 bar left over. So you'll see the 1 and 1/6. So that was using fraction bars. Here's another way to help you to add fractions with unlike denominators. Another way is to try finding the least common multiple. Now this is important. The LCM, least common multiple, just abbreviated it there. The LCM is the smallest number that is a multiple of both denominators. You can find the common multiples by showing products of both numbers. And just a reminder, a product is what you get when you multiply two numbers, 2 and 3. These are factors of 6, but 2 times 3, my product is 6. So that's what I'm looking for. Multiples of 3. Well, I would start with 3 times 0 is 0. 3 times 1 is 3. 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. Let's see if that's enough. Now I'm going to find multiples of 4, because I'm going to try to find the least common multiple of 3 and 4. If 3 and 4 were my denominators, I was looking for a least common multiple. This is how I would set it up. So now let's find the multiples of 4. 4 times 0, 4 times 1, 4 times 2 is 8, 4 times 3, 4 times 4, 4 times 5. Now I can go through and find my common multiples first. So I can find all of my common multiples and circle those. Well, we know 0, 4, 3, 8, there's 12. And that's all that I have on this list. Okay? But my least common multiple of 3 and 4 is, well, you can't use 0. So my least common multiple is going to be 12. So again, if 3 and 4 were my denominators in the fractions that I was trying to add, I would find the multiples of both of those denominators and find the smallest one, other than 0, that they have in common, and that's going to be the least common multiple of those two numbers. So let's see it in action with a fraction problem. All right. So let's look at this. If I'm going to add 2/3 plus 1/2, first thing I notice is my denominators are different. I have a 3 and I have a 2. So I need to find the least common multiple of those two numbers. So my multiples of 3. 3 times 0 is 0. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7. I'm going to stop there and see if I can find something. Okay, my multiples of 2, just my multiples of 2. 2 times 0, 2 times 1, 2 times 2 is 4, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7. We'll go all the way out to 7 this time. Alright, so the first thing I can do is I can find all of my multiples. Well, we know 0, but we know we can't use it. 2, 4, they both have 6, 9, they both have 12. Okay, so those are my common multiples. My common multiples of 3 and 2 are 0, 6, 12, and there are probably some more if I were to go on out. But I'm looking for my least common multiple, the smallest number that these two have in common, and the smallest is going to be 6. So I come back to my problem, and I'm going to have to find equivalent fractions now, because I found a number that both of these have in common. This is my least common multiple. Now, this is where you get to meet my friend, the backward Z guy. He's here. He's a superhero. Once you come in and you find the least common multiple, now what do? Well, I always call backward Z guy, and backward Z guy comes in to help. So we're going to put his name, we're going to call him backward Z guy. And if you look at him, you'll see that he is a backward Z. So I'll call him, hey, backward Z guy, can you come help me? And he's going to come and help me find these equivalent fractions. So I'm going to say 2 will go into 6. How many times? 2 times 3 is 6, so that'll go 3 times. 3 times 1 is 3, and so my 3 is going to go there. Backward Z guy to the rescue. So he's going to help me again. 3 goes into 6. How many times? 2. 2 times 2 is 4. So 2/3 is equal to 4/6. 1/2 is equal to 3/6. Well, now I have common denominators, so all I have to do is add the numerators. 4 plus 3 is 7. My denominator stays the same. 7/6, I know that that's more than 1, so I have to reduce my fraction to 1 and 1/6. Let's try another one. 1/4 plus 3/8. My denominators are different, so I'm going to come find my multiples of each of my denominators. Multiples of 4, 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. If I need to, I'll go on further out. Multiples of 8, 8 times 0, 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5. So I have a pretty good list. Let's see if I can find a least common multiple other than 0. So we know 0 is going to be 1. There's 8. See if they have other common multiples. Oh, 16, 24. So I'm thinking 4 and 8 probably have a lot of common multiples, but I'm only interested in that least common multiple. So the least common multiple other than 0 is going to be 8. So if I come over, alright, so I've got my common denominator. What do I do now? I call backward Z guy. He comes swooping in to save the day. And I go, 8 goes into 8. How many times? 1. 1 times 3 is 3. 4 goes into 8. How many times? 2. 2 times 1 is 2. Thank you, backward Z guy. And he flies away because now I have common denominators and I just have to add my numerators. 2 8s plus 3 8s is 5 8s, and that is in lowest terms. So that's a second way, is to find your least common multiple. The last way that I'm going to tell you about to add fractions with unlike denominators is the butterfly method. And this may look familiar from when we found equivalent fractions before. If I'm going to add 2/4 plus 1/6, see my problem in there, I'm going to butterfly it. 2 times 6 and 1 times 4, and underneath the antennas, 6 times 2 is 12, 4 times 1 is 4, but this time I have to do something different because I'm adding. So I'm going to multiply. 4 times 6 is 24, and that's going to be the butterfly's tail. So then I just add what I get up here. 12 plus 4 is 16. 4 times 6 is 24. Well, I can look at that and I can tell right away that that is not in lowest terms. So I would have to go in and reduce. They get 8. 8 will go into 16 2 times. 8 will go into 24 3 times. 2/3 is in lowest terms. All right, so let's try one together. 1/5 plus 3/10. All right, so I'm going to butterfly. I'm going to give him some wings this way. I'm going to give him some wings this way. Remember the antenna. 10 times 1 is 10, so I'm going to put that here. 5 times 3 is 15, so I'm going to put that there. Got to have the tail this time because we're adding fractions. 5 times 10 is 50. So now I just have to come across and add. 10 plus 15 is 25. And I know when I multiply down here, I get 50. Now the thing with the butterfly method is you're always going to have these really large numbers in your fraction, and you're going to have to reduce every time. Because I can look at that and tell 25/50 is not in lowest terms. So let's say, well, I know I can look at that ending with 5 and an ending with 0. They're both divisible by 5. So 5 will go into 25 5 times. 5 will go into 50 10 times. Well, I can go further because I still have multiples of 5 here. So 5 can go into 5 once. 5 can go into 10 twice. So this is just another method that you can use. It is important that you understand all 3 methods. Know how to use your fraction bars to find your answers. Know how to find your least common multiple to get equivalent fractions. And the butterfly method, you can use that maybe to go back and check your fraction bars or go back and check your least common multiples. So make sure that you understand and know how to do all 3 different ways.